Now this question is basically addition of bromine in presence of CCl4. Bromine will dissociate into Br plus and Br minus, and the addition happening over here is anti-addition. Now clearly we are supposed to find in which of them addition give rise to diastereomers. As we have mentioned earlier, diastereomer means that few chiral configurations in two molecules will have same configurations and few it will be the reflections. Now if we talk about this one, which means there should be multiple chiral carbons. In the first example, if bromine adds over here, right, in that case there would be presence of only one chiral carbon, which is this one, which means it can form enantiomers but not diastereomers. Second, in the second example, we have bromine which is attacking over here, and let's see what the configuration would be. Now in one case, for let's say if we say methyl is outside the plane and bromine is inside, right? Okay. In this can be one because anti-addition has to happen, and the second molecule would be where methyl is down and bromine is up, and this side bromine is the inside the plane because it's example of anti-addition. Now clearly we can see over here that these molecules are enantiomers. These are enantiomers. Now if you put this molecule above this molecule, this would be the mirror image, right? So these are enantiomer, but these are not diastereomers. Then we have the third example. Now in this case the double bond is symmetrically placed. So what do we have? We have this methyl which is outside, and we can have two cases when you have this bromine outside the plane and this addition of bromine, this orientation is inside, and second molecule where because nothing is happening over here, it still remains outside the plane, but here this bromine gets inside the plane and this bromine is outside the plane. Again, if you put this molecule above the previous one, you will find that, or maybe side by side, if you just put this molecule side by side, you will find that these are mirror images, which means again these are examples of enantiomers. Now then the D, in this case, which is of course the example in this case, so we have methyl on this side, and if we take the two cases, let's say bromine attacking over here from outside the plane and this bromine attaching inside the plane, and the second molecule, because nothing is happening, this methyl is outside the plane, this bromine is inside the plane, and this bromine is outside the plane. Clearly we can see that we have multiple carbons, and these are not reflections. If you place one above the other, this methyl is outside, so this should have been inside, but it's not so, so it's not a reflection. If you put side by side, then this is a reflection, but this and this is not a reflection, which means you have multiple star carbons, and few configurations are same. For example, this configuration and this configurations are same. However, you will have inversion over here and here, and inversion over here and here, which means few chiral carbon have same kind of orientations and the remaining have the opposite one, which means this is a suitable candidate for diastereomers, and therefore we say that example in this case our answer is D.